In this video, we're going to learn how to solve a three-variable system by using the strategy of elimination. So to begin solving a three-variable system using elimination, we first have to pick a variable that we could easily manipulate and eliminate from the three equations. So what I notice here is that this single y right here makes y very easy to eliminate if we combined it with one of these other two equations. So I'm going to choose to eliminate y. It doesn't matter which variable you choose to eliminate, but I like to pick the easiest ones possible. So I'm going to choose, and I'm going to record this, to eliminate y first. So what we're going to have to do is we're going to have to break these equations up into pairs and eliminate y from two sets of different pairs. So what I'm going to do is label these equations 1, 2, and 3. And I'm going to use equation 3 twice because of this single y value. So what I'm going to do first is I'm going to pair up equation 1 and 3. So here I have 4x plus 2y plus 3z is equal to 12, and I'm pairing it up with equation 3. So I have 6x minus 1y plus 4z is equal to negative 3. So I've paired up equations 1 and 3 here. Now, this isn't set for elimination just yet because I need to do some manipulating on that second equation. So I'm going to multiply this second equation through by 2, because what that will do is turn this into 12x minus 2y plus 8z is equal to negative 6. So I've rewritten this equation, multiplying it by 2, to get that equation down there in red. So now that I have these set up to eliminate, I'm going to add straight down. So 4x plus 12x is 16x. The y's here, because they're opposite signs, cancel out. And my z's add together to be 11z is equal to 6. So notice I've created a new equation with two variables. So I've eliminated y out of the problem. Now I need to pair up two more equations. So what I'm going to do is I'm still going to use this equation 3, and this time I'm going to pair it up with equation 2. So here I have 2x minus 3y plus 5z is equal to negative 7. And then my second equation is equation 3, and I have 6x minus 1y plus 4z is equal to negative 3. And in order to set this up for elimination, I'm going to multiply this second equation through by a negative 3 to make that coefficient of y a positive 3. So if I multiply all of those terms through by negative 3, I end up with negative 18x plus 3y minus 12z is equal to 9. So now I am elimination ready, so I'm going to add straight down. So we end up with negative 16x plus 0y plus, or you can do subtract 7, whatever you choose to do, because 5 and negative 12 make negative 7z, and that's equal to a positive 2. So just to recap what we've done so far, we looked at our original three equations and we picked an easy variable to eliminate. In this case, we picked y because there was a single y in one of the equations. Then we paired these up into two pairs. We put equations 1 and 3 over here, and we eliminated the y value from those. We then also had equations 2 and 3 over here, and again we eliminated the y variable out of those. And what you'll notice now is by doing so, we have two equations and two variables, x and z. So what we're going to do here is we're going to pair these two up and create a two-variable system with two equations and solve that using elimination. So here we have 16x plus 11z is equal to 6. And then we have negative 16x minus 7z is equal to 2. And what's really great about this problem is it's already set up for elimination. We can see that we can easily eliminate the x values because we have a positive 16 and a negative 16x. So if we add straight down here, we eliminate our x's and we end up with 4z is equal to 8. And if we divide both sides by 4, we find that z is equal to 2. So we now know our z value is equal to 2. We have our z value, and what we're going to do now is we're going to work backwards, and we're going to find our y value and our x value by working backwards with some of the equations we already see on the screen. So what I'm going to do now is I'm going to take the z value, and I'm going to choose to find x first, because I notice that I have two different equations, both that contain x and z. So I'm going to use this equation here that I'm highlighting in purple. You could also use this other equation that's boxed in blue. It doesn't matter. But we have negative 16x minus 7. I know that z is equal to 2, and that's equal to 2. So here I have negative 16x minus 14 is equal to 2. I add 14 to each side. Negative 16x is equal to 16. Divide by that negative 16, and I find that x is equal to a negative 1. So at this point, I have both x and z. And because I have both x and z, what I can do now is I can work even further backwards, and I can find what y is equal to. So I can take my x value of negative 1, my z value of 2, and I can take both of them and put them back up into an equation up here to help me solve for that missing value of y. And it doesn't matter which equation you pick, you just need to pick one equation. So I'm going to pick the first equation because it's got a lot of positives in it, and I like dealing with positives a little bit more than negatives. So I'm going to give myself a little bit more room to work here. Erase some of these extra lines in here. And I'm going to utilize that first equation. So I can see I have 4 times my x value of negative 1 plus 2y plus 3 times my z value of 2 is equal to 12. Well, then this is negative 4 plus 2y plus 6 is equal to 12. So that's really 2y plus negative 4 combined with 6 is 2. And that's equal to 12. Subtract 2. We have 2y is equal to 10. Divide both sides by 2. And y is equal to 5. So I have now found all three of these values for x, y, and z. And what these values represent are they represent the x, y, and z values, where if you plugged this combination into any of these three equations, the combination would make all three equations true. Now, our last step here is to write our answer appropriately. So you're going to write your answer as an ordered triple of negative 1, 5, 2. So let's work through one more example together just to make sure we've got this down. So remember, to start, we need to choose the first variable that we want to eliminate. And in this case, you have a lot of options. You could either choose x, y, or z. It doesn't matter. There's a single one in each equation, so we just have to pick one. And for the sake of this problem, I'm going to pick to eliminate x first, just because I would like to eliminate x first. It doesn't matter what you pick. You just need to commit to one. So I'm going to choose to eliminate x first, and I notice that I have equations 1, 2, and 3, with equation 1 being the one where I have a single x. So what I'm going to do is I'm going to pair equation 1 up with equations 2 and then equation 3. And in both sets, I'm going to eliminate x. So if we start over here with equations 1 and 2 paired up, remember I'm going to eliminate x here. So I have x minus 2y plus 3z is equal to 7. And then I have 2x plus y plus z is equal to 4. Now remember, my goal here is to get the coefficients of x to match, but to have opposite signs. So I'm going to multiply this first equation through by a negative 2. And I end up with negative 2x plus 4y plus a negative 6z, or you can put minus 6z, it doesn't matter, is equal to negative 14. So now if I add these two equations together, I eliminate my x's, I end up with 5y, then that becomes a negative 5z is equal to a negative 10. So here I have an equation that has two variables. So now I'm going to pair up another pair. So we already paired up 1 and 2. So now I'm going to pair up 1 and 3. So here I have x minus 2y plus 3z is equal to 7. Negative 3x plus 2y minus 2z is equal to negative 10. And remember, my goal again is to have the x's have similar coefficients but opposite signs. So we're going to multiply this top equation through by 3. So here we have 3x minus 6y plus 9z is equal to 21. And now if we add those two together, we eliminate our x's, we end up with negative 4y plus 7z is equal to 11. So I now have a second equation that contains both y and z. So now we have two equations that contain two variables. So we're going to group these together and we're going to create a two-variable system out of them. So here we have 5y minus 5z is equal to negative 10 and negative 4y plus 7z is equal to 11. Now unfortunately this one isn't as easy as the last one. We are going to have to do some manipulating here in order to eliminate a variable. So I need to choose a variable to eliminate. I'm just going to pick y because I'm picking y. You could pick z and that would be perfectly fine. So I need to get these coefficients to match, so I'm going to multiply the first equation through by 4 and the second equation through by 5. And in doing so, I will get a positive 20 and a negative 20 as my coefficients for y. So here I multiply through and I end up with 20y minus 20z is equal to negative 40. And then I have negative 20y plus 35z is equal to 55. So if I add straight down here, my y's eliminate. I'm left with 15z is equal to 15. And if I divide both sides by 15, I find that z is equal to 1. So I've now found the first of my variables. I know that z is equal to 1. So now all I need to do is work backwards to find my other values for y and for z. So I need to go backwards and I have to put z into one of my two equations that contained both y and z. It doesn't matter which one I pick, so I'm just going to go back and pick this one right here. So I'm just going to plug that in quick. I can see that I have negative 4y plus 7z is equal to 11. Well, y is equal to 1, so this is negative 4y plus 7 times 1 is equal to 11. Subtract 7, subtract 7. Negative 4y is equal to 4. Divide by 4, and I find that y is equal to negative 1. So I've now found my second variable. And then I'm going to take both z and y and plug it back into one of my original equations. It doesn't matter which one I pick. I'm going to pick this middle one because it contains all positive numbers and I prefer to deal with positive numbers. So now I'm going to write that down here. So I have 2x plus my y value of negative 1 plus my z value of 1 is equal to 4. So I have 2x, well those two added together equals 0, so it's 2x equals 4. Divide both sides by 2, and I find that x is equal to 2. So what I have here are the values for x, y, and z that if we plug them into any of these three equations, will make all three equations true. That is the point where they cross in 3 dimensions. So we have our ordered triple of x is 2, y is negative 1, and z is 1.